Surprisingly, actually, the Animer also rearranges in high yield to give us this product, differing only in the configuration here. And this product actually could be reduced at the ketone to give us X-ray quality crystals to confirm the relative stereochemistry around the 7-membered ring. You'll notice there are actually 6 stereocenters here, plus the anomeric one. You'll also notice maybe that in comparison to Forbol, we haven't done too badly. If you believe that this bridging ether could be opened up, then we have the correct configuration here for the angular hydroxyl, the correct configuration here. Here we have this benzylidene acetal with a downward pointing oxygen right where we need one. Here we've got a little bit of a problem. We want a hydrogen and we want the opposite configuration. But we thought maybe if we could open up this ether, we could do an elimination reaction and eventually correct this stereochemistry. And this would be a handle for eventual introduction of the allylic alcohol. So the problem was actually 2 problems. Problem number 1, we did a model here where we have no other substituents on the 2 rings. If we really wanted to make Forbol this way, we would have to go back and use a substituted cyclopentanone and a substituted cyclohexene oxide. We weren't sure whether this same chemistry would work out so well. The other problem is we never found a good way to break open this ether. Lacking that sulfur, things just don't work so well. So we went back to this other idea, the idea that we would build the BC system, and then from this, we had everything we needed to put in the 5-membered A ring and the 3-membered D ring, based on earlier precedent by Wender. And that sets both of these stereocenters. So this stereocenter is set predictably by alkylation from the opposite side as this isopropenyl group. Then when we do the Michael addition, that's actually under thermodynamic control. And we end up with these 3 groups in equatorial orientation, and this sulfur is in an axial disposition, which now allows us to do the addition into this carbonyl using the cerium enolate with very high facial selectivity from the top. And once we add in, that alkoxide spontaneously lactonizes onto this ester to give us the 5-membered lactone. Now we can take the T-butyl ester, convert it to the acid, and do a careful selective half reduction of the lactone to the lactol. And having done that, convert this back into the methyl glycoside and generate the methyl ester, which allows us to substitute in the sulfur where we need it, and then convert the ester, as usual, into the diazoketone. And this works beautifully to give us an 82% yield, this product. Again, with complete retention by the migrating sulfur, and with almost everything we need for Forbol. Of course, we have to get rid of this isopropenyl group, and we can do that to generate either of these isomeric enones. This one probably a little bit more useful in order to introduce the cyclopropane ring here. And I've already pointed out that we can use this ketone to put in everything we need for the A ring. All right, so quick summary. I started out with oxygen heterocycles. I moved on to nitrogen heterocycles, where we're basically using cyclic ylids to build heterocycles. And now, towards the end, I pointed out we can also use it to build medium-sized rings, either carbocyclic or heterocyclic. And I've told you about some progress towards these 3 natural products. So all that remains is to acknowledge the people who did the work, as well as the funding agencies that supported this work. So I already mentioned Fred Marmstetter was the one who did the polyether work, as well as having been the first person to explore the carbocycle formation by oxonium ylids. John Vanecko, Marmstetter was my last Utah student. He moved with me to Alberta to help me set up my lab there, and also did some fantastic work. John Vanecko did almost all of the nitrogen chemistry I told you about, pyrolyzidine, silicon-directed. Tina Bott here did the azetidine, most of the azetidine chemistry, and is working on the catamaran A. Graham Murphy worked with Fred Marmstetter on the medium ring methodology and did the first generation route to Dactylol and is now postdocing. He's being followed up by Jeff Johnston, who is, I think, going to finish Dactylol very soon. And Leah Kale did all of the medium ring ether and Lorentz synthesis. And Craig Stewart, there he is, did all the 4-ball work. One last acknowledgement I have to make. Professor Toyota, of course, without his very kind invitation here to participate in the HeteroGP program, I would not be able to stand here today and give you this lecture. He's been a fantastic host to me for the last 3.5 weeks, and I really can't thank him enough for his kindness in allowing me to visit and in taking such good care of me while I was here. So, and let me, of course, acknowledge explicitly the HeteroGP program, which funded my visit here to OPU. And so with that, I think that's my last slide. So the last thing I'll do is tell you once again what a great time I've had here at Osaka Prefecture University. I've really enjoyed getting to meet so many of you and spending some time here in Osaka. And finally, let me thank you for your very kind attention and patience. So domo arigato.